So the rate of change of a function is how much the y-axis variable, whatever you're plotting on the y-axis, how much that's changing relative to how much whatever you're plotting on the x-axis is changing. So it's a kind of ratio, and it shows how quickly that y is changing relative to x. So and you can have positive rates of change where y is increasing as x increases. You can have negative rates of change where y is decreasing as x increases. Or you can have zero rate of change where y just stays what it is, whatever x is doing. So I've got some examples, and I want to show you kind of how to just interpret them and then graph them so you can see what they look like visually. So let's look at this first one here. 200 miles per 2 hours, and I could write that actually like that, 200 miles per 2 hours. Okay, so the rate of change is the how quickly the y's are changing over how quickly the x's are changing, and that's a delta, and that just means change. Okay, it's probably a little advanced, so that's a little bonus there for you. So change in y over change in x. So that means the top number of a rate of change will be graphed on the y-axis, and the bottom number, or the second number if you write them like I wrote them here, will be the x. So if this rate of change is a change of miles versus hours, that means that the y-axis would be is where I would plot the miles there, and then on the x-axis we're measuring hours, so I'll just put hours here. So my distance is changing 200 miles for every 2 hours. So if I wanted to graph that, I could just label some points here. So if these are hours, say it's 1 hour, 2 hours, 3 hours, 4 hours. And then let's make the scale of the y-axis so I can actually fit all this on here. So let's say that that's 100 miles, and that's 200 miles, and etc. So the y's go in increments of 100. So if I'm going 200 miles in 2 hours, so if I increase the x by 2 hours, I go from 0 to 2, then I'm increasing my y by 200 miles. So I could have a point there. Assuming we're starting at 0 here. So I could keep going. I could increase another 2 hours here on the x-axis, and then when I increase 2 there, then I increase another 200 miles up. My y increases by 200. So what I would get is a line like this. I didn't draw that exactly right, but basically showing that my y's are increasing by 200 whenever my x's increase by 2 hours. So let me delete this, and then I'll show you the next rate of change. Okay, let's look at this rate of change. Negative 10 gallons for every 3 minutes. So I know that the rate of change is the change in the y variable over the change in x, and these deltas here just mean change. So this rate here I could rewrite as negative 10 gallons. That's how much the gallons are changing over 3 minutes. So that whenever the minutes change by 3, they increase by 3, then my gallons are going down by 10. So this means I want to put gallons on my y-axis. Gallons. Okay, and I want to put minutes on my x-axis. And I'm I'm decreasing gallons. So imagine, like, a container filled with some kind of liquid. Let's say hot tea. Say I've got a giant thing of hot tea. Here's the steam coming off. Um, and it's every 3 minutes. It's the amount of hot tea in there is decreasing by 10 gallons. So I want to start with it being full. So um, pick whatever you want. Let's see. Let's say it's a 50-gallon thing. So let's make the scale of the y-axis. Let's make it go by 10. So 10 gallons, 20 gallons, 30 gallons, 40 gallons, and 50 gallons here. Okay, and minutes are going by 3. So let's just say we'll be able to see it if we just do minutes like this. 1, 2, 3, 4, 5, 6. That's 6. Okay, so I'm starting at let's just say I'm starting at 50 gallons. Okay, if they don't give you a starting value, just pick something that makes sense. 50 gallons. So every 3 minutes, I'm decreasing that by 10. So I'm going to increase by 3 minutes on my x-axis, but I'm going to decrease my gallons by 10. So if I've hit 3 minutes, then I've gone down to 40 gallons. And if I keep going and go to 6 minutes, then I've gone down another 10 gallons. I could keep going, 7, 8, 9 minutes, but then I've decreased down to 30, or was that 20 gallons? So what I would get is a line that would look like that, and then I could see that right about here is when I'd run out of hot tea, and I'd have to make some more. So what is that? 7, 8, 9, 10, 11, 12, 13, 14. I don't know if that's quite right. Anyway, I drew the line kind of squiggled, but you get the basic idea. These the y-axis variable is decreasing as I increase with the x-axis variable. Yeah, and then you could do this one be similar to that, negative 54 meters per second. You're comparing meters with seconds, so you would put meters on the y, seconds on the x, and see if you can do that one.